KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to focus on next problems 25 and 26. Okay, right. First we will see the first problem, that is what 25 in this class, right? So in our previous class we completed 24th problem. Now 25th is the starting. See here. First I will read the problem, then we will go for solution. See here, right? What should be the distance between the object in exercise 9.24? That is what we discussed in the previous problem, right? What should be the distance between the object in exercise 9.24 and the magnifying glass if the virtual image of each square in the figure is to have an area of 6.25 millimeter square. 6.25 millimeter square. So to get this much of magnification, that is what 6.25 millimeter square, what should be the distance between the object? What should be the distance between the object in exercise 9.24 and the magnifying glass, right? So as simple as such, we have to find the distance between the object and magnifying glass to achieve this much of magnification. That is what the area also he mentioned, that is what 6.25 millimeter square. Next, would you be able to see the squares distinctly with your eyes very close to the magnifier? Very close to the magnifier, right? So this is what like second thing, right? So first you have to focus on the calculation, then we will go for this one. See here, the magnification in area. The magnification in area is equal to, that is what 6.25 millimeter square divided by 1 millimeter square. This is what regarding the object or figure. So if you do this, you will get it as 6.25, right? So 6.25 is the magnification. 6.25 is the magnification regarding the area. Okay. Then what about linear magnification? Linear magnification, that is what square root of 6.25, it will give us 2.5, right? Now by using this formula, that is m is equal to v by u, m is equal to v by u, v is equal to mu, this is what vm. So v is equal to mu. When v is equal to mu, already we know that m value, that is 2.5, and u is as it is, that is 2.5 u. V is equal to 2.5 u. Now by using this formula, that is what relation among focal length, object distance and image distance, you can write 1 by v minus 1 by u is equal to 1 by f. So this relation we know. So we are substituting this value in this relation along with that is what focal length, which is 10 centimeter, okay, right? So I am going to substitute, that is what in place of v I am writing 1 by 2.5 u, 1 by 2.5 u, okay, 1 by 2.5 u minus 1 by u, 1 by 2.5 u minus 1 by u is equal to 1 by 10. Just in place of v we are writing 2.5 u. Next do this calculation, so that you will get it as u is equal to minus 6 centimeters. U is equal to minus 6 centimeters, right? Hence V is equal to, because you know that V is equal to 2.5, you know. So when we got that value of U, that is minus 6 centimeters, then V is equal to 2.5 into U. So 2.5 into minus 6, it will be minus 15 centimeters. So whatever he is asking, distance between the object and the magnifying glass, that is what here 15 centimeters. V is equal to 15 centimeters, right? Next, he is asking, would you be able to see the squares distinctly with your eyes very close to the magnifier, right? See this. As the virtual image is closer than the normal near point, as the virtual image is closer than the normal near point, that is what 25 centimeters, it cannot be seen by the eye distinctly. So here we want to know the reason. So what is the reason? Virtual image is closer than the normal near point. Virtual image is closer than the normal near point, that is less than, that is what, almost nearly 25 centimeters. This is the reason we cannot see the eye distinctly. Okay, right. Now, so we completed 25th problem. So here we found two things. One is the distance between the object and the magnifying glass. To get this is the magnification of 6.25 mm square. After that we cross check, that is what it is not possible to see, but it is possible in other case. But here he is asking, would you be able to see, right? So as the virtual image, as it is not possible to see distinctly, the reason is virtual image is closer than the normal near point. Normal near point, that is what 25 centimeters, so that it cannot be seen, so that it cannot be seen by the eye distinctly, right? Next question, 26th. Answer the following question, right? So this problem is like that is what A, B, C, D, E. So 5 things they have given. These 5 things, in these 5 things he is cross checking and he is trying to get the reason and he is asking to check like that. Okay. So you please be focused. I will explain you one by one. Otherwise, now I am explaining all these A, B, C, D, E questions and then I am going for solution, means you may have some sort of confusion, right? So that's why first I will explain you A, then I will go for a solution of A, right? Then I will go for B, then I will go for a solution of B, right? So like that. Okay. See here. So A the angle subtended at the eye by an object is equal to the angle subtended at the eye by the virtual image produced by a magnifying glass. Produced by a magnifying glass. I will repeat once again. The angle subtended at the eye by an object is equal to the angle subtended at the eye. Angle subtended at the eye by an object is equal to the angle subtended at the eye by the virtual image produced by a magnifying glass. Full stop. So he has given some information. In what sense then does a magnifying glass provide angular magnification? In what sense then does a magnifying glass provide angular magnification, right? So they have given some information and asking in what sense, so in what meaning, in what direction does a magnifying glass provide angular magnification. Okay, right. See this, see here, it is true that angle subtended at the eye by an object is equal to the angle subtended at the eye by the virtual image produced by a magnifying glass. Produced by a magnifying glass. Okay, but when a magnifying glass is not used, when a magnifying glass is not used, an object has to be placed at a distance of 25 centimeters. See the situation. When a magnifying glass is not used, an object has to be placed at a distance of 25 centimeters. Okay, but the use of a magnifying glass allows us, the use of a magnifying glass allows us to place the object much closer to the eye than at 25 centimeters. Than at 25 centimeters. Full stop. The closer object has larger angular size than the same object at 25 centimeters. The closer object has larger angular size than the same object at 25 centimeters, right? So it is the sense that a magnifying lens produces angular magnification. Magnifying lens produces angular magnification, right? So what he is saying is, whatever the information he told in the question, it is true. It is true. Then why it is happening like that? Why we have to do like that? Means when a magnifying glass is not used, the object has to be placed at a distance of 25 centimeters, right? But the use of magnifying glass allows us to place the object much closer to the eye than at 25 centimeters. So this point is giving that importance, that is the usage of the purpose of magnifying glass, the role of magnifying glass. Okay. So when we keep the object closer to the 25 centimeters, that is what the closer object has larger angular size than the same object at 25 centimeters. So by keeping the object at 25 centimeters, by keeping the object closer to the 25 centimeters, will give us larger angular size. Larger angular size, it leads to give more magnification. That is what we want. It is the sense that a magnifying lens produces angular magnification. Angular magnification, right? I hope you understood. That is the reason he is telling, right? So why, on what sense a magnifying glass provide angular magnification? Means because of using magnifying glass, you can keep the object closer to the 25 centimeters, which leads to get more magnification or more angular magnification. Okay, right. Next, B. In viewing through a magnifying glass, one usually, right, in viewing through a magnifying glass, one, so whoever the person who is doing that, in viewing through a magnifying glass, one usually positions one's eye very close to the lens. Full stop. Does angular magnification change if the eye is moved back? The question is, this is the information what he is saying generally we are doing when we are going to see the image. But his question is, if you change, that is what, does the angular magnification change if the eye is moved back? If the eye is moved back, right? The answer is yes. The answer is yes. So what happens? The angular magnification decreases. Yes, the angular magnification decreases slightly if the eye is moved back, right? Yes, angular magnification decreases slightly if the eye is moved back. This is because angle subtended at the eye would be slightly less than the angle subtended at the lens. Okay, but this effect is negligible when image is at much larger distance. So whatever this effect, keeping eye close to the magnifying glass or having somewhat distance, is negligible when the image is at a larger distance, much larger distance. But for the question what he is asking, the answer is yes. Angular magnification decreases slightly if the eye is moved back. What is the reason? Means angle subtended at the eye would be slightly less than the angle subtended at the lens. Okay, that is. But in practical, this effect is negligible because when the image is at much larger distance. Next, C. Magnifying power of a simple microscope is inversely proportional to the focal length of the lens. Right? Okay. What then stops us from using a convex lens of smaller and smaller focal length and achieving greater and greater magnifying power? Right? So first he is saying that the information what is true. So what is the information? magnifying power of a simple microscope is inversely proportional to the focal length of the lens, right? Then what stops us from using a convex lens of smaller and smaller focal length and achieving greater and greater magnifying power? Okay, see here. First, grinding of lenses, that is what, decreasing the size of the lens, okay, and making some adjustments, the physical portion of the lens, right? So first, the grinding of lenses of very small focal length is not easy. Grinding of focal length, grinding lenses of very small focal length, is not easy. Moreover, right, more important, if we decrease focal length, both spherical and chromatic aberrations become large. I will repeat once again. If you decrease the focal length, both spherical and chromatic aberrations become large. And moreover, in this way, you cannot get the magnifying power of more than 3. You cannot get the magnifying power of more than 3 with a simple convex lens. With a simple convex lens. However, if we use an aberration corrected lens system, you can increase the limit by a factor of 10 or so. Right? So the grinding of lenses is difficult, and if you are going to grind, it leads to spherical and aberration problems. By having these problems, you can get the magnifying power only more than 3, that's all. It is not possible to get more than 3. So 3 or less than 3 only possible. But instead of that, if you are using aberration corrected lens system, you can increase this limit by a factor of 10 or so. So on and around 10. Okay. Right. Next, D. It is what? See here, ma. Next question, that is what? D. Why must both the objective and the eyepiece of a compound microscope have short focal length? Why must both the objective and the eyepiece of a compound microscope have short focal length? Okay. So he is asking he is giving the fact, asking the reason. In case of compound microscope, right? First, we have to know what is the formula, that is what is the relation, and what is the magnifying power mathematically, what is the magnifying power of a compound microscope. So that's very well, that only I am writing here. M is equal to M naught into ME, that is equal to V naught by U naught into 1 plus D by FE, right? That is equal to F naught by U naught minus F naught into 1 plus D by FE. 1 plus D by FE. Okay, right. Here, angular magnification M naught of the objective will be large when U naught is slightly greater than F naught. U naught is slightly greater than F naught. Okay. That is what, because of the mathematical equations. This is the sentence he is saying because of this mathematical arrangement of these terms, of these quantities, right? Since microscope is used for viewing very close objects, you know very well what is a microscope, right? So in our biology lab, right, you are using microscope. So when you are using microscope, where you are going to keep the object? Almost very close to the object, no? So that is the reason, since microscope is used for viewing very close objects, U naught is small. Obviously U naught is small. Consequently, F naught has to be small. Moreover, the angular magnification ME of the eyepiece will be large if FE is small. Moreover, the angular magnification ME of the small will be large if FE is small, because FE is in the denominator. Right? So this is the reason, these are the things, because of these things, both the objective and the eyepiece of a compound microscope, have short focal lengths. Okay, Right. Now we are going to see the next thing, and this is the last one. When viewing through a compound microscope, our eyes should be positioned not on the eyepiece but a short distance away, a little distance away, right? A little distance away from it for best viewing. I will repeat once again. When viewing through a compound microscope, our eyes should be positioned not on the eyepiece but a short distance away from it for best viewing. This is the correct information. Why? What is the reason? Why we are doing like that? Okay. And how much should be that short distance between the eye and eyepiece? Between the eye and eyepiece. That is the question, right? So he has given some information and asking reason. What is the reason to do like that? Okay. What is the reason to do like that? See here. So while answering this E, we have to know what is eye ring. What is eye ring? I will tell you first. The image of the objective in the eyepiece is known as eye ring. I will repeat once again. The image of the objective in the eyepiece is known as eye ring. Okay, full stop. And listen carefully, ma. All the rays from the object refracted by the objective go through the eye ring. You cross check yourself whether it is correct or not. All the rays from the object refracted by the objective lens go through the eye ring. Okay, therefore it is an ideal position for our eyes for viewing. Therefore, it is an ideal position for our eyes for viewing. If you place our eyes too close to the eyepiece, we shall not collect much of the light and also reduce our field of view. If we position our eyes on the eye ring and the area of the pupil of our eye is greater or equal to the area of eye ring, our eyes will collect all the light refracted by the objective. So here two things. One is the amount of light, and next thing is field view. So if you close our eyes, if you keep our eyes too close to the eyepiece, we will not collect much of the light. When you will not collect much of the light, you can't see the object, that is what with full of brightness. At the same time, whatever you are doing, that is what the field of view is also very less. Okay. If you position our eyes on the eye ring and the area of the pupil of our eyes is greater or equal to the area of the eye ring, our eyes will collect all the light refracted by the objective. Okay, that is what. Next, the exact location of the eye ring depends on the separation between the objective and the eyepiece and focal length of the eyepiece. Right? I will repeat once again. The exact location of the eye ring depends on the separation between the objective and the eyepiece and also the focal length of the eye lens eyepiece. Okay, that is what I am saying. So here I didn't write the answer for E, but I am saying, you just listen. So the question is, when viewing through a compound microscope, our eyes should be positioned not on the eyepiece but a short distance away from it for best viewing. Why means to get more amount of light. That light helps us to see the object clearly. You know, for example, in one dark room, somebody will keep an object and they are asking them to see, right? Similarly, in one room there sufficient amount of light is present, one object is kept and somebody is asking to see that. So what is the difference you are experiencing? The same difference, this difference related to the amount of light, that is one thing. And field of view, right? So these two things makes us to see the object clearly, and correctly also. Okay, that is what he is saying. So that is the reason we are keeping our eye not too close to the eyepiece. Okay, suppose if you position our eyes on the eye ring and the area of the pupil of our eye is greater or equal to the area of the eye ring, our eyes will collect all the light refracted by the objective, right? So the exact location of the eye ring, depends on the separation between the objective and the eyepiece and the focal length of eyepiece. Okay, so that is what he is saying. So generally, when we are going to see something with the help of these optical instruments, right? So first we are going to adjust the position of eye. So where we separate the position of our eye to see the object, which is comfortable means even you have to think from biological point of view. That is what stress of eye, right? So eye should not get too stress. If eye is giving the stress means you cannot see the object clearly. That is one of the problem, right? So in many aspects, so the aspect what I told you is according to the question. In some other aspect, stress is also important. So the relaxed eye we need to see the image of the object clearly and correctly. Okay, right. So in this class we focused on two problems. One is problem number 25 and another one is problem number 26. In case of problem number 26, every point is important. So here they have given 5 questions and asking us to answer, right? So we answered correctly. So you just go through this 26th question again and again. Why I am saying means, so if you listen once, you may not get it. So listen again and again and see the answer and my explanation again and again. Okay. So finally you have to get one conclusion in your own perception, right? Not my perception, right? So I am explaining in my own perception, right? So you try to observe the answer and try to memorize. Try to memorize means not blind memorizing, not learning. First understand, right? So if you understood the same information what we understood here, we can apply for many problems, the problems which we are going to answer in case of either NEET exam or mains exam. So this problem 26 is important, right? So I can say that very, very important, because here 5 things are very important. In these 5 things we are talking about the abilities, capabilities and power of optical instruments and some other also. That is what magnifying glass, either convex lens or concave lens, etc. Okay, thank you. In the next class we will continue.